At this point, cleats have been manufactured, veneer has been cut and dried, and we're now ready to fabricate wire-bound containers. A stapling machine unit is comprised of an automatic stitching machine and a rock fastener machine. This unit is versatile, capable of manufacturing a wide range of container sizes and designs. Material for fabricating the containers is supplied to the crew at the stapling machine. Cleats and slats for making standard containers can be positioned in the stitching machine's conveying system automatically by cleat hoppers and slat feeders. This function can also be performed manually with the addition of several workers. The stitching machine conveys cleats and slats under the stapling heads. Staples, which are automatically formed from coils of stapling wire, are driven over binding wires into the slats and cleats. At times, containers are printed during fabrication to identify the type of container and/or the manufacturer's name. Some manufacturers pre-print this information on their slats. This container shown being fabricated is a corn crate. At the rock fastener machine, the closing loops are formed. It takes only approximately 1.5 seconds to cut the binding wires, form the loops, and drive and clinch the wire prongs into the leading and trailing slats of each container. As the wire-bound blanks exit the rock fastener machine, ends that were previously manufactured on a similar machine unit are then attached. Crate ends can also be secured by a mechanical end attacher. The unitized containers are then bundled and palletized. Bundling can be done by automatic machine as shown or by hand. These bundled wire bounds are then loaded onto trucks or freight cars for delivery to customers. Note that they are shipped in a knockdown form to conserve valuable space during shipping and storage. Containers such as these are used at a grower's packing house or in the field for packing fruits and vegetables. In an industrial wire-bound manufacturing operation, surface dry lumber is delivered to the plant from the lumber yard and placed on conveyors, which transport it inside to the cutoff department. This material, which already has been processed to desired thickness, will be used to make cleats for various wire-bound containers. At the cutoff saws, the material is cut to predetermined lengths. The material then goes through a rip saw where it is cut to width. When properly sized to length and width, the cleats are diverted to two lines leading to tenoners, which miter the cleats. The resultant chips, off-grade, and scrap material are used to fuel the boilers. In most industrial wire-bound plants, faceboards are produced in the resaw department. Blocks of timber called cants are cut to length and width, then fed through a gang ripsaw to produce multiple slats of desired thickness. In some plants, faceboard material is delivered to the cutoff department already cut to desired thickness. It is then cut to length and proceeds through ripsaws which cut it to desired widths. As the boards emerge, they are inspected and graded. Throughout the entire material processing operation, rigid quality standards are followed. Because of the greater size and complexity of industrial wire bounds, compared to the fruit and vegetable crates shown earlier, cleats and faceboard material are placed manually into the machine's conveying system. This container is used to ship automotive engines. This pallet container, which has diagonal faceboards, is designed to prevent racking of the package and its contents during shipment. Veneer is often used as faceboard material for some industrial applications. This container is designed for insulators. A small plywood container, this one for 60mm mortar ammunition, is shown being fabricated. Ends for this container are shipped separately and are attached at the munitions packing plant. Printing can be done on the faceboard material prior to box fabrication. In this instance, faceboards are being printed according to government specifications. These wire-bound containers are representative of what you've just seen being manufactured. Fruit and vegetable crates, military packaging, seafood containers, and industrial packaging for sinks, bathtubs, water heaters, and pallet containers for bulk shipments of myriad products. Mass-produced, these wire-bound containers are versatile, strong, even in rain or high humidity conditions, lightweight, thus using much less material, economical, and they provide excellent product protection.